Trig equations, algebra 2, trigonometry, regions. To solve a trig equation, it's much like solving for x in a regular equation. And that's the first thing you need to do is you need to solve for the function, much like solving for x. So let me do this first example step by step with you and kind of explain these steps as I go. So the problem we have here is what is the solution set for 2 cos theta minus 1 equals 0 in the interval 0 to 360. Now the interval is important because that means that we're looking for answers, and notice that I said plural, answers between 0 and 360. If this specifies something else like 0 to 90 or 90 to 180 or 270 to 360, then it might be looking for an answer in a specific quadrant. By saying 0 to 360, we're really talking about everything here. So the equation that we're working with is 2 cosine theta minus 1 equals 0. The function is cosine theta. You have to treat that like it's x, almost like you're solving 2x minus 1 equals 0. You're trying to, get x alone. You're going to add 1, divide 2. You want x equals. Same thing here. Treat this exactly like it's an x or a variable. You're trying to get it alone. Basic equation maneuvers will get us there. So you're going to add 1 to make it 2 cosine theta equals 1. You're going to divide 2 to get cosine theta equals 1/2. Because we know 1 divided by 2 is 1/2. So that's the first thing you do is you just kind of solve for the function. Just like if it were 2x, again, I'll write that up there. 2x minus 1 equals 0 would become x, 2x equals 1, and then x equals 1/2. That's just exactly what you did here. Just pretend cosine theta is x. Some people actually like to write it as x, solve for x, and then, all right, oh, well, I'm not solving for x, I'm solving for cosine, so I could go back and remember that it's cosine theta equals that, not x equals that. But so if you want to temporarily make this an x to help you solve it, you certainly can do that. But that's the first step, is solve the function. But that's not it, because we want the angles here. So the first step is to solve the function like you're solving for x. That's exactly what we did. We want cosine theta equals, or you want sine theta equals, or tangent theta equals. That's what you want. Then determine the proper angle that satisfies the given function ratio. So now we're doing inverse functions to kind of figure out when is cosine 1/2. Now, these are going to be the special angles we're working with, the 30, the 45, the 60s, and we worked with these a lot on the unit circle. So maybe you know when cosine theta is 1/2. Is it the 30, the 45, the 60? Maybe you have to use your calculator. If you're using your calculator, that means you're doing inverse cosine 1/2 equals theta, which is fine, and that's the second function in your calculator. Remember, the second function, the inverse function, is used to find angles, and that's exactly what we're doing. So if you do second cosine 1/2, your calculator gives you 60 degrees. But here is the warning. Be very careful with what your calculator tells you, because your calculator answers can be deceiving. What's meant by that is the calculator might not know what quadrants you want to explore. But for now, let's just go with what the calculator says. The calculator says theta equals 60 degrees. So determine the proper angle that satisfies a given function ratio. So that's how we got our 60 degrees. When is cosine 1/2 at 60 degrees? This is probably the most important step and the part that people will mess up the most. Don't forget to explore all quadrants, often 2 solutions. So what's meant by that, and notice that for this multiple choice question, we have 2 answers for each of these. What you end up with at this point right here is you want to determine what quadrants you're dealing with. How do you figure that out? Well, you have cosine theta equals 1/2, but most importantly, you have positive 1/2. And when is cosine positive? Cosine's positive in quadrant 1. We already have that answer. But it's also positive in quadrant 4. So we need that answer. And that's really where I think these problems get tricky, because solving for the function, that's no big deal. You've solved equations for years. Typing inverse function into your calculator, again, no big deal. But solving that other angle is really the tricky part. And so, maybe we should have added that to the steps, is that after you solve for the function, maybe right here, determine, that's very sloppy. Let me rewrite that again. Determine quadrants. So once you solve for x, if your ratio is positive, what two quadrants is that function positive in? If your ratio is negative, if your function is negative, your ratio is negative, what two quadrants is that function negative in? So you need to figure out what two quadrants, and there's almost always going to be two, unless it's quadrantal. If it's on the axes, that's where it gets a little bit different. But if it's an angle in a quadrant, then there's always going to be a second answer. And so the fact that we have a positive 1/2 here tells us that the function is positive. And where is cosine positive? Well, remember, cosine is like the x value. The x value is positive in quadrants 1 and 4. So you can type your calculator, but your calculator is only going to give you one answer. You have to figure out the other. But it's easy, or at least hopefully it's easy, because the answer you have, the answer the calculator gives you, it's going to be a reference of that. So I know I need an answer in quadrant 4. It's got to be the same distance away from the x-axis as the one that I have. So you're looking for the quadrant 4 reference of 60, which is 300, because in quadrant 4, that's how far we are from 360. Remember that? The quadrants in quadrant 2, it's how short of 180. In quadrant 3, it's how much past 180. And in quadrant 4, it's how short of 360. And so your two answers are going to be references of each other. They're going to be the same distance to the x-axis as each other. So the answer is not just 60, it's also 300. And so that's why the answer here is D. So you need to solve the function like you're solving a regular equation. And right there is a good point, right? As soon as you know if that fraction is positive or negative, determine what quadrants you're dealing with. Then determine the proper angle by doing inverse functions or just using your exact value table or your memory. Don't forget that there's probably going to be two quadrants where that function is positive or negative. And then step D is to check it in your calculator. And that's probably the easiest part. And since this was multiple choice, we actually could have done guess and check. But all we're going to do now is simply type in cosine 60 and see if I get 1/2. I do. Cosine 300. Do I get 1/2? Yes, I do. I get positive 1/2. Now, if I typed in, say cos 120, I'm going to get a half, but it's going to be negative, and I'm looking for a positive 1/2. If in the process of solving this equation I got negative half here, well, then I'd be looking for quadrants 2 and 3, and then that would be different answers. Okay, let's try one more example. How are we doing on clock? 8 minutes. We got time for one more. So again, 0 to 360, 2 sine x plus rad 2. So first I want to solve for sine x. I want to get this alone. So I'm going to minus rad 2. So 2 sine x, and x is just like theta here, equals negative rad 2. And then I'm going to, because this is 2 times, so I'm going to divide by 2, and I'm going to get sine x equals negative rad 2 over 2. Right now, I'm going to determine my two quadrants. I see sine. I see negative. Sine is negative in quadrants 3 and quadrants 4. So in the end, my angle x better be an angle in quadrant 3 and in quadrant 4, because that's where sine is negative, because sine's the y value, and the y values are negative down here. I can get one of those answers by typing it into my calculator. Now remember, you might just reckon, all right, rad 2 over 2, that comes from the 45. Now 45 is not going to be the answer because that's in quadrant 1, but it's going to be a reference of 45. 45 short of 180, 45 short of 360. But let's let our calculator get our first answer. So if we do second sine, negative radical 2 divided by 2, our calculator tells us negative 45. And remember that rule I mentioned probably at this point a week ago, that if you ever get a negative angle, that means it's going the other way. And so this is in quadrant 4. But I'm not going to write negative 45 here because we want positive answers between 0 and 360. Basically, if you ever get a negative angle on your calculator, add 360 to it to convert it to its positive angle. So our calculator told me negative 45, but really it's trying to tell me 315. So 315 is my quadrant 4 angle. So 315. What my calculator's not telling me is my quadrant 3 angle. But again, you recognize the reference here is that 315 is 45 degrees away from the x-axis of 360. Well, this angle also needs to be 45 degrees away from the x-axis, but this x-axis over here is 180. And 45 past 180 is 225. But the beauty is I can certainly check this in my calculator, because now I'm going to type in sine 315, and I'm looking for negative rad 2 over 2, but as a decimal, that is negative 0.707. And sine 225, same deal. All right, so that's the solving trig equations. You're going to solve for the function, determine the two quadrants where that function is, that sign. Let your calculator help you out with one of them, but the other one is the tricky part, but always remember it's going to be the same distance to the axis away. So we'll practice this in class.